Let's learn about the various frame allocation algorithms used by the operating system in order to allocate frames for the incoming pages. So this is what we're going to see in this video. Let's now move into the need for frame allocation. Now, when we talk about the need for frame allocation, it goes like this. The main memory of the operating system is divided into various frames. All of us know this. Why we divide the OS into various frames? That's because we have our virtual memory divided into a number of pages, and we need to load each page into one frame in the main memory. So that's the reason why the OS is divided into various frames. And the process, that is, which is divided into pages, is stored in these frames. And once the process is saved as a frame, the CPU can start running it. As a result, what happens is the operating system must set aside enough frames for each process. So whenever I'm going to execute a process, the OS must make sure that there are enough frames available for the process in the main memory so that the process can execute and run to completion, thereby completing its task. Hence, what the operating system will do is it uses certain allocation algorithms, which are called as frame allocation algorithms, to assign the frames to the various process. So this is the need for frame allocation. Now, what are the factors that need to be considered for frame allocation? Just like that, we cannot assign frames to any process. Suppose a process requires 4 frames, just like that, you cannot allocate all the 4 immediately. So you cannot assign more frames than the total number of frames available. This is one mandatory factor that has to be considered. Say, for example, a process requires 10 frames. You should not allocate more frames to it, right? Which are than the number of frames which are available. Currently, assume that there are only 10 frames available. And if a process requires 15 frames, I cannot allocate 15 frames because the number of frames available itself is less. So I have to take this first point into consideration. The second point I need to take into consideration is I must only allocate a specific number of frames to each process. So this limitation is due to 2 factors. The first is that when the number of frames assigned drops, the page fault ratio grows, decreasing the process execution performance. Secondly, there should be sufficient frames to hold the multiple pages that any instruction may reference. So these are the factors to be considered while doing frame allocation. Now, the OS uses 2 main frame allocation algorithms called as equal allocation and proportional allocation. So the first algorithm is called as equal frame allocation, and the second algorithm is called as proportional frame allocation. Let's see each one in detail now. Now, coming to equal frame allocation algorithm, in equal frame allocation, what is done is the processes will be assigned equally among the processes in the OS. Okay, so the frames that are available will be given equally among all the processes. Say, for example, I assume that I have currently 30 frames available and I have 7 processes available with me. So current availability is 30 frames and 7 processes. So if I want to do equal allocation, that means I should divide these 30 frames equally among 7 processes. That is 30 divided by 7, which will be 4 frames for every process. And 2 frames are not assigned. They will be available in the free frame pool as such. This is called as equal allocation. That is, whatever frames are available among the currently running processes, the frames will be divided. This is called as equal allocation. Now, you have another algorithm called as proportional frame allocation algorithm. Now, what is done in proportional frame allocation and why do we move from equal allocation into proportional allocation? We will see shortly. Now, coming to what is proportional frame allocation, in proportional frame allocation technique, what is done is this technique will assign frames based on the size needed. Based on the size needed for execution and the total number of frames available in main memory. So here it's nothing to do with the number of frames and number of processes. It is to do with number of frames and size of the process. So this is what is meant by proportional frame allocation. So what happens is I allocate frames based on a formula. That is, I will say if my process is say PI, and the size of my process is SI, then AI, which is the number of allocated frames to process PI, will be done based on SI by capital S into M, where small SI is the size of the process PI, capital SI is the total size of all the processes put together. S represents the total of all process sizes. And what is M? M will represent the currently available number of frames in the system. When I do allocation based on this formula, I'll be able to give the frames to the processes based on the sizes. So that is the advantage of proportional frame allocation. That is, say for example, I have say 2 processes. Let me now give you a very simple example and tell you what is this proportional allocation. Let me say I have a process P1, okay, and then I have process P2 with me, okay. Now if P1 size is say 10 KB and P2 size is say 100 KB, and assume I have say 50 frames, if it is going to be equal allocation, then P1 will get 25, P2 will get 25. Whereas I'm not doing a fair allocation. Why? Because P1 size is very small. It's only 10 KB. P2 size is large. It is 100 KB. Therefore, I go in for proportional allocation based on the sizes. I hope all of you are very clear with the advantage of proportional frame allocation. Thank you.